Hello everyone, it's Mrs. Slauson. Welcome. Today we are going to be solving rational equations. So what you're going to be noticing is that we have an equal sign now in our problems where we didn't have an equal sign before. So we're going to start out with some really basics on problem 3 and 4 before we get into the tougher problems, which there is another number 4 and then 5 and 6. So the idea is on problem 3 is we want to ask ourselves, 3/5 plus how many fifths would give us 4/5. So the idea is, what would that x have to be so that I get 4/5 when I'm done? And that x would just be a 1, because if I put 1 here, remember when you add and subtract fractions, you need a common denominator, and that common denominator just goes along for the ride. But what we're actually doing is all the math in the numerators. So what I'm really just asking myself is, since I have this common denominator, is 3 plus how much gives me 4, and then I can see that that is 1. So when I go to problem 4, the first thing I'm going to suggest you do is subtraction on all the subtraction problems. And when I refer to subtraction, I'm referring to the subtraction between the two fractions. I would suggest you go there and you add the opposite. So I'm going to make this adding and make the numerator the opposite. And so again, whenever I add or subtract fractions, I do need a common denominator, and what I notice is that I don't have one. So my least common denominator between the three fractions is 2. My first fraction is good. I can leave it as x over 4, sorry. But for the second fraction and the third fraction, I need to get those denominators to become a 4. So whatever I do to the bottom, multiply it by 2, I do to the top, and the same on the last one. So my new fraction, besides x over 4, is going to be negative 10 over 4 equals 14 over 4. So just like before, again, when you add or subtract fractions, now we have that common denominator. And when you add or subtract fractions, that common denominator just goes along for the ride. So that's why you see the 4 on the right side. So what I really only have to worry about is just solving for the numerator. What number plus negative 10 gets me to 14? So what number plus negative 10 gets me to 14? So I can just solve for x. I can just, add 10 to both sides. And when I'm done, I get negative 4. Okay? All right, so let's get to problem 4. So what I want to do first is find my least common denominator. And you've done this already before. So what I'm going to have to do is try to factor all my denominators. Here they are. On the other side of the equal sign, there isn't a denominator. So remember, the first step. All right, so I had to pause there for a moment because the background noise. So anyway, the first step of all factoring is going to be looking for a GCF. In that first fraction, the denominator x squared minus 16, there isn't a GCF. So with two terms, what I'm going to do is a difference of squares. So this denominator is going to factor now into x plus 4 and x minus 4. The second fraction, x minus 4, I can't factor at all, so I'm good to go. I'm going to leave that one alone. And before I begin any solving, what I should do first is the subtraction in between the two fractions. I'm going to add the opposite. And again, when I add the opposite, I always want to apply that to the numerator. So if you notice, hopefully you can see at this point what your least common denominator is going to be. If you don't, remember, I've shown you this fraction table you can make. So here's fraction 1. It has a factor of x plus 4, and it has a factor of x minus 4. I'll be erasing this in a little bit. My second fraction has a factor only of x minus 4, and my third fraction has nothing. So what I need to do to find my least common denominator is to bring these all down. X plus 4, bring this down to x minus 4, and now this is what I need all the fractions to have right here. All right, so looking at my different fractions, my first fraction has x plus 4, x minus 4. It has the least common denominator, so I don't have to do anything with it. My second fraction only has an x minus 4 in the denominator, so what it needs is an x plus 4. So I'm going to multiply the bottom by x plus 4, and remember, whatever you do to the bottom, you do to the top. And then my other fraction, the 3, actually needs both of them. So I'm going to make a little fraction bar here. I'm going to put x minus 4 and x plus 4 on the bottom. Oops. And whatever I do to the bottom, I do to the top. So at this point, what I need for you to realize is that like in problem 3 and problem 4, once you have that least common denominator, you actually don't need to worry about it. You can, as I've used before, you can use that, you can just let it go. You only need the numerator to solve for x. So what I'm going to do now over here is just write down what's in the numerator. So in my first fraction, I have a 12. In my second fraction, I have a negative 24 with an x plus 4. So let me show you what I'm talking about. There's the 12, there's the negative 24, and the x plus 4. And then in my other side, in the third fraction, the other side of the equal sign, I have the 3. And then I have an x minus 4 and an x plus 4. So what I'm going to do is just clean this up. So the first thing I'm going to do is distribute that negative 24 first. That's going to give me negative 96. And then on the other side, what I've got here is, in my class, you know how we talked about the neighbors meet the neighbors. I've actually got 3 neighbors. So what I'm going to do is just multiply these numbers first, which, if you think about it, these are the factors of that x squared minus 16 over here. So right here, let me circle it. So when you multiply those, you are going to get x squared minus 16. So I'm going to go ahead and do that. And now I'm going to distribute that 3 through. And then I'll clean up the left side real quick. So I get negative 24x minus 84. I just combined these two numbers. And now what I'm going to notice is I have more than one type of x because I'm ready to solve. And with more than one type of x, I will have to factor. So I'm going to get it into standard form. I will get it equal to 0. So that means I'm going to move this stuff over to the right side. So first I'm going to add the 24x, which gives me 3x squared plus 24x. So that's gone from over here. And then I'm going to add the 84 over, and it can combine with this negative 48. So when I have negative 48 and I add 84 to it, I get 36. And now it's in standard form. Remember, whenever you see more than one type of x, you do have to factor. So the first step of this factoring over here is going to be looking for a GCF, and I can take a 3 out. That's going to make that a lot easier. So I get x squared plus 8x plus 12. Hold on, I got a little dog out. And now with those 3 terms, I'm going to make my x. So I need factors of 12. That can get me to 8, and that's going to be 6 and 2. And so joining 3, remember, I'm going to do this quick way of factoring. The only way to get x squared right here is to multiply an x with an x. And now I'm going to use these side numbers, and I'm going to ask myself, all right, x times what can give me this 6x? And that would be a positive 6. And then I'll do x times the other part, x times what can give me this 2x, and that is a positive 2. And remembering this is equaling 0, so now I'm going to take my factors, just the ones with x, set them equal to 0. I'm just asking myself what makes them 0, and I get x equals negative 2, and I get x equals negative 6. So those are my 2 answers. Now, one thing we're going to have to check for are what are known as extraneous solutions up here. I'm highlighting now. The idea is with extraneous solutions, even though we did all the math to get the answer, is that an answer that would work if we plugged it back in? So I'm going to go back to the original problem. I am going to erase my work so we can kind of focus what's here. I do want to keep that, factored the denominator though. And the idea is if I put those answers back in, what wouldn't work? So remember, in fractions, the denominator cannot be 0. So this can't be 0, this can't be 0, and this can't be 0. So what x value would make that 0? That would be 4. So when I solve, I just want to make sure I don't get 4 as an answer, because if I were to get 4 as an answer, that would be considered an extraneous solution. But we don't have 4 as an answer. We have x equals negative 2 and x equals negative 6. All right, let's try number 5. So the first thing I need to do is find that least common denominator. So I'm going to factor. So I'm going to try to factor this first. So I always look for a GCF. I don't see one. This will factor into, so I'll make this little X, I'll erase it later for work. I need factors of -6 x squared that get me to 1x, and that's going to be a 3x and a -2x. And now that quick factoring, the only way to get this x squared here is to have x squared, or I'm sorry, x times x. And now I use these side numbers, so x times what would get me this 3x, that would be a +3. And then x times what can get me that -2x, and that would be a -2. All right, so that's been factored. Let me erase my x for work. And let's look for our least common denominator. So keep going. The second fraction doesn't have a denominator. The third fraction, you can't factor x minus 2. So again, if you are having trouble seeing that least common denominator, you can make that little fraction table. The first fraction has an x minus 2 as a factor and an x plus 3. The second fraction has no denominator, and the third fraction has an x minus 2. It will join this. And if you just bring everything down, you will get your least common denominator. So each fraction should have an x minus 2 and an x plus 3. So when I look at the first fraction, it's good to go. It has both of them. When I look at the second fraction, it doesn't have anything. So I'll have to multiply the bottom and the top by the x minus 2 and x plus 3. All right, I paused. I wanted to make that a little bit smaller in appearance. So what I'll do is I'll take the 2 and I'll multiply the bottom by x minus 2 and x plus 3. And whatever I do to the bottom, I'll do to the top. I'm going to really squish that in there. And when I go to the third fraction, it has the x minus 2, but it doesn't have the x plus 3. So I'll multiply the bottom of that fraction by x plus 3, and whatever I do to the bottom, I do to the top. So again, once the denominator is the same all the way throughout, I don't need to worry about it. I can let it go. So what I'm about to write down is just going to be the numerator. So I have a 5 equals 2, and then that 2 will multiply this x minus 2 and x plus 3, plus, and then here's my third fraction, there was the original numerator, and then I'll have to multiply it by the x plus 3. So again, what I'm showing you right now is just this. I wrote down the 5, the 2 multiplying to all of this, and the x minus 3 multiplying to all of that. So now I just have some cleanup work to do. So the 5, nothing happens here. The idea is, again, here I've got these neighbors or things that I have to multiply. And where I'm going to start is right here, because when you multiply these, you're actually going to get back to this x squared plus x minus 6. So I'm just going to go ahead and write that down. Okay. And then when I have these neighbors meet, you'll get x squared. You'll get a 3x, but then you'll get a -3x, which will cancel out, and then minus 9. So I'm still working on cleaning this up. There's the 5. I need to distribute my 2 through to all of these. Still cleaning up. I'm going to erase this fraction table over here, so I got a little bit more room to work with. And so I'm just moving over here. So I got 5. I'm going to combine these 2x squared and x squared for 3x squared, 2x, and this -12 and this, or -12 and minus 9 will give me -21. Again, I notice I have more than one type of x, so I'm going to have to get it into factored form. So I'm going to subtract the 5 over. And that gives me subtracting 26. All right, again, so I had to pause there for a moment. So again, because there's more than one type of x, we are going to try and factor. So I'm going to be looking for factors of -78 that get me to 2x. And as you go through your list of factors, what you're going to find out is that this is actually not factorable. So this is a tougher problem, but it's something that you should expect. Because remember, when you can't factor and you're sad, you need to cheer yourself up with a little song, you use the quadratic formula. So that's what we're going to do here. So let's quickly identify what A, B, and C are. and go to our quadratic formula. So it's going to go x equals opposite of b plus or minus square root. I'm going to take b and square it, so that's 4. Then minus, minus 4 times a times c. And then all of that's divided by 2 times a, so 2 times 3. So from here, what you can do is, if you have your calculator, you could just work on typing that in, not with the radical, just 4 minus 4 times 3 times negative 26. So when I do that, just so you know and are aware of it, that your calculator is actually doing the order of operations. So it's subtracting here. So you get 4 minus negative 312. Then if you add the opposite, it's plus 312. Again, this is all over 6. But maybe you just type that in and you're going to realize that that's 316. All right, so let's talk about your answer. The idea of the 316, again, I know this is a tough problem, but is we should see if 316 or any factors of 316 are perfect. So as it turns out, there are. And I can break 316 down into the square root of 4 and the square root of 79, and then go one step further and make it 2 root 79, because the square root of 4 becomes a 2 over 6. So again, this is a good answer. Nothing's wrong with it. This is a little bit better. And then the best answer would be to, what I've told my students, is to make this triangle. The radical doesn't get to be part of the triangle. And is there a number that can go into all of those? And sure, I can divide all of those by 2. So when I'm done, I'm going to have negative 1 plus or minus the square root of 79. I don't need to put a 1 in front of there, over 3. So this is a great answer. Again, any of these that I'm circling are, in my opinion, acceptable answers, especially, with 316 being such a big number and finding all of the factors. You could also use your calculator and find the decimal values too. All right, let's do our last example. So number 6. So again, the first thing I want to do is try to factor my denominators. So x plus 1, 2x, 2x. None of those can factor. So as far as my least common denominator, maybe at this point you're going to see that each denominator needs an x plus 1 and it needs a 2x. So if it doesn't have one of those two pieces, that's what I'm going to give it. The first thing I'm going to do is go to the subtraction in between my two fractions and add the add the opposite. And now when I look at my first fraction, what I realize is that it has the x plus 1, but it needs a 2x. So whatever I do to the bottom, I do to the top. My second fraction has the 2x, but it doesn't have the x plus 1, so I'm going to multiply the bottom by x plus 1, and whatever I do to the bottom, I do to the top. And the same on my third fraction. So it needs an x plus 1, so whatever I do to the bottom, I'm going to do to the top. And there are slightly different ways you can do this problem, but this is the way I'm going about it. So again, once you have that least common denominator, you don't need for it to solve, because the answer is going to be all in the numerator. So what I'm going to do is just write down my numerator. So starting with this 2x and 3x, I'm going to multiply those, and that gives me 6x squared. And then I'm going to multiply my second fraction, the negative 5, with x plus 1. That one I'll just write out. And then my third fraction on the other side of the equal sign is 3 with x plus 1. So I'm going to quickly clean up, distribute. So 6x squared plus negative 5x plus negative 5 equals, distribute here. I get 3x plus 3. What I'm going to do is, since there's more than one type of x, I'm going to get everything on one side. So I'm going to subtract 3x over. When I do that, it'll join the negative 5x and become a negative 8x. And I'm going to subtract the 3 to join the negative 5 and get a negative 8. All right, this is going to equal 0. So now I am ready to factor this problem. So the first thing I'm going to do is look for a GCF. There is one. I'm going to take a 2 out of all of these, and once I take that 2 out, I'll have, so there's the 2, I'll have 3x squared, I'll have negative 4x, and negative 4. And so now what I'm going to do is try to factor this. So what I'm doing is I'm going to look for factors of negative 12x squared that get me to negative 4x. And those factors are going to be a 6x and a 2x, with the 6 being negative. And now I'm going to factor. Again, I'm factoring just what's the highlighted part. So again, when I multiply these terms, I have to get to 3x squared, and I'm only going to do that with a 3x and an x. So now I'm going to ask myself, using these side numbers, is 3x times what can get me this negative 6x, and that's a negative 2. And then x times what can get me that 2x, and that is a positive 2. So now I can set each factor equal to 0 and solve. All right, so let's go for the easier one, which is this one. I'm just going to add 2, so one answer is 2. On the other one, I'm going to subtract the 2, and then I'm going to divide by 3, and so my answer is negative 2/3. So again, I just want to make sure that these solutions that I'm circling aren't extraneous solutions. So on number 6, going back to the problem, I got to remember, I'm going to do a little bit of erasing here now, all that stuff, is that, when I do get my answers, that I got to make sure that those answers don't make these denominators worth 0. So in my first fraction, I got to make sure that negative 1 isn't an answer, which it's not. And then in the other two, I just want to make sure that 0 is not an answer, because negative 1 and 0 will make my denominators 0. So I'm good to go. These two are my answers. So at this point, you're going to move on to an assignment, step 2, big ideas. You have to complete that, and after that you're going to go to step 3, which is a Schoology quiz. On the big ideas, you can enter the answer up to 5 times. But again, you have to get a 60% for it to be considered complete. And when you do the Schoology quiz, I'm going to let you attempt the quiz 2 times. And again, you have to get a 60% on that. So if you're not understanding this, please reach out to me. Send me an email, message me through Schoology. You can use the Remind app. Any of those things are great options. That's it. Bye.